So this time we're going to try to work out the selection sort algorithm. So the selection sort will process the array and then look ahead look ahead throughout the rest of the elements in order to help us figure out how to sort the array. So the process of selection sort works like this. We're going to have two loops. One's going to be nested within the other. We'll start with 5. That'll be the outer loop, and then we'll search everything to the right of it until we've been able to identify the lowest value. And when we worry about the lowest value, we're going to worry about its subscript, not its actual value. We're going to compare values, but we're going to make decisions then on swapping and reordering based on the subscript. So the first time this loop is going to go, it's going to say, okay, I'm comparing against 5. Is 3 smaller than it? Yes. Is 1 smaller than it? Yes. Is 6? No, no, yes, no, yes, and then no, no. And this will end up being the last one we found that was smaller, the smallest, because it's in fact going to find, is 5 smaller than 3? No. Is 3 smaller than 5? Yes. Is 1 smaller than 3? The rest of these are not smaller than 1. 0 is the only thing left to be smaller than 1, and so we'll get this subscript, which will be 987, and then we'll swap the two. So 5 will end up at the end of that first loop over here in this position. The next iteration will start at 3, and we'll search everything remaining. 0 will be out of the way, so we don't have to worry about that interfering. So that's the basic process. Let's write our loops for it. So we're going to start the outer loop at 0, and it's going to process the loop normally with one exception. The reason that I captured size, even though I'm using constructor list, is I'd like to use that in my loop to make this very verbose. So we're going to make sure that I less than size minus 1. We're doing this because when we hit the end of our array, our inner loop, you see, is actually going to look 1 ahead. And we don't want it to ever go out the bounds of the loop. So the outer loop will only process this much, but the inner loop, when it gets to the very end, will just look for 4 and 7. So here's our inner loop. We'll use j, and this will become I plus 1. So it's going to be 1 greater than I. And then this will end at the loop's normal termination, size. And then we'll increment it normally. Let's take a moment to visualize what this might look like. So we can kind of see the process by which this would touch each element. So we'll do a little cout. So we'll do unsorted I, the outer loop. A little space in there so we don't get too lost. And then we'll do unsorted j. So we'll see the process by which it compares these values without it doing any logic right now. So as we see at the very beginning, we start at 5 and we compare it against everything else in the array. But here, down at 9, which is closer to the end, we actually compare it against far fewer things. So there's only 3 things to compare here, whereas the entire array needs to be compared. So as we see that this slowly gets faster as we start shuffling things off to the left that we can consider sorted. So we'll put this aside because we might use it later. So one of the things we have to do is we have to keep track of our current position so that we can figure out what the next lowest position is, where we're going to swap some values. So I like to use the variable current position for this. Whereas that will start at the current value we're comparing against, and then this will be how we write our for loop. So if unsorted at j, so this is the one to the right of the thing we're comparing against, happens to be less than the unsorted at the current position, which could change, and in fact likely will during the course of our loop. If it does, though, we're going to update that position to equal the new one we just found. That's it. That's the hard part. Now we have to swap. So in order to swap, we're going to have to take one value out and replace it, and then put the other one in its place. So this is possibly done without a temporary variable, but for sake of verbosity, let's use a temporary variable. So we're first going to cache the cache or copy, the original value we're searching for. We will then replace it at its position, so replace its value with the smallest one we've now found, which is at current position. And then we will move current position to the old value. So in this case, we'd switch 5 and 0 with temp. Now, one of the things you want to be careful of is you want to make sure that this swap happens after this inner for loop finishes. If you don't, it'll kind of look sorted, but you'll miss a couple of values at the end because they'll kind of get excluded. So let's write a quick loop and see how this looks. And then that's it. We have selection sort. So we're just going to iterate over the entire array. Got a variable here. And we're going to use something similar to this loop, or this output, making things easier on us. I don't really need that part. And let's see what happens. So as you can see, the loop is now sorted. Now you may say to yourself, how do I get, that's the ascending version of the loop, how do I get the descending? Well, the truth of the matter is you could rewrite the entire for loop to make it go in backwards order, so you could get the maximum value instead of the minimum value. The truth is, though, once an array is sorted, flipping the other side is really just a matter of reversing it. So as you saw in class, we could reverse that array by just iterating and switching all those values around. So really sorting is usually done in an ascending or descending only, and then if we need the opposite, we flip it. That's it.